It takes 24 hours for the Earth to spin on its axis, and within this time, different countries will be lit up by the sun, and others cast into the dark. The whole world is not lit up at the same time. This is why it can be morning in Australia and nighttime in Africa. This is also why we have time zones. They are governed by the Earth's rotation. As the Earth takes 24 hours to complete a rotation on its axis, it is divided into 24 segments by lines of longitude, each representing an hour of time and a different time zone. The prime meridian, passing through Greenwich, England, serves as the reference point for time zones. This is where the world's time begins, known as Greenwich Mean Time, or GMT. Anything to the right of this line, known as the Eastern Hemisphere, is ahead of time, and anything to the left, known as the Western Hemisphere, is behind in time. Time zones are typically 15 degrees of longitude apart, each representing 1 hour of time difference from GMT. In this illustration, we are moving left of GMT across the Western Hemisphere, so we deduct an hour for each 15-degree rotation. Now let's take a look at a map to see how this works a bit clearer. The prime meridian is marked, indicating where Greenwich Mean Time sits. Remember, anything to the right of this band is ahead of time, and anything to the left is behind time. Greenwich Mean Time is set at 12 noon in this example, so let us scroll through the ascending and descending time zones. As you can see, 1 hour is added for every band on the map as we move across the Western Hemisphere. On the contrary, 1 hour of time is deducted as we move across the Eastern Hemisphere. Let's show some examples. Eastern Standard Time, EST in New York, is 5 hours behind GMT, while Japan Standard Time, JSP in Tokyo, is 9 hours ahead of GMT. But what happens when you travel across time zones? How do you calculate the time difference between two different locations? Let's take a look. Using the lines of longitude that separate each time zone by 15 degrees, we can apply some basic math to calculate time differences. Let's say we want to calculate the difference in time between Rome and Tokyo. First, we need to check what lines of longitude these places sit on. We are going to round them to the nearest denomination of 15 to simplify. Rome is on a longitude of 15, and Tokyo is on a longitude of 135. We need to calculate the difference in longitudes, so we deduct here. 135 minus 15 equals 120. We know that each 15-degree longitude represents 1 hour in time, so we divide 120 by 15 to give us hours. 120 divided by 15 equals 8 hours. As Tokyo is in the Western Hemisphere, it is ahead of time, so Tokyo is 8 hours ahead of Rome. This formula can be represented as longitude of location 1 minus longitude of location 2 divided by 15 equals time difference to the nearest hour. Let's introduce the time zones again to check our answer. And there you have it, an 8-hour time difference. Great, so now you understand time zones and how to calculate them. So next time you watch a sunset, just think, someone else on the other side of the world is watching that very same sun rise.